In lesson 7.4, we're going to talk about the properties of logarithms. The first thing I want to go over is what a common log is. That is a logarithm with a base of 10. It's often written simply as log. If you see a base missing, you can assume it's a 10. This is the log that you find on your calculator, the common log. And you'll see it throughout today's lesson. Let's go over the different properties. The first property is the product property. It relates addition with multiplication. If you have two logarithms you're adding, you can change them into a single logarithm you're multiplying. Or if you have one that you're multiplying, you can split it up into two logarithms to add. Our little shortcut is that multiplication goes with addition. The quotient property is that division goes along with subtraction. If you have two logarithms you're subtracting, you can rewrite them as a single logarithm that you're dividing. And the last property is called the power property. It's when you have a number multiplied to the whole logarithm. You can bring that number up and make it an exponent. If you have an exponent, you can bring it down and change it to a multiplication. So we're going to use these three properties to solve our next problems. The first type is they ask us to write it as a single logarithm. When I look here, I see the plus sign. So I'm going to use my product property. You add two logarithms, I can combine them into one by multiplying. So I take my log base 5. Once I've used them, you can get rid of it. That will help you remember you only write the logarithm once. And then I would take the 4, change addition to multiplication, and go 4 times 3. My final answer is log base 5 of 12. On letter B, log base 6 of 25 minus log base 6 of 5. I see the subtraction sign, so I'm going to use my quotient property. If I have subtracting two logarithms, I can rewrite it as a single logarithm using division. So I'm going to write my log base of 6. I've used that logarithm, so I'm going to cross them off. I then change my subtraction into a division problem, and I get 25 divided by 5. My final answer would be log base 6 of 5. If you can divide, you should. Anytime you can simplify, do it. Letter C. The same properties can work whether you have 2, 3, or 4 different terms. I want to write these as a single logarithm, so I'm going to start with the first two. Log base 2 of 4 and log base 2 of 2. I'm going to combine those into a single logarithm. Because it's addition, I'm going to change it to multiplication, and I get log base 2 of 8 minus log base 2 of 8. My answer should probably be 0 if you take one thing and minus it, but let's look at it through the properties. I'll write these two as my single logarithm. Log base 2, subtraction changes to division, which would be 8 over 8. 8 over 8 is the same thing as log base 2 of 1. And when I look at this as if it were an exponent, I would say 2 to what power is equal to 1? Well, the only power that gives you an answer of 1 is 0. And that makes sense because up here at this step, I had log base 2 of 8 minus log base 2 of 8, which should be 0. So you can see how the division property works. Let's try one now where you have a number in front of the logarithm. This is 2 times log x and 3 times log y. I'm going to use the power property. I have my number times the logarithm. I can take that number and bring it up, making it an exponent. So take the 2 and bring it up as an exponent of the x, and the 3 comes up as an exponent of the y. So I have log x squared minus log y cubed. Now I can combine the two into one single logarithm. It's a subtraction, so I can change it into division. It would be log x squared over y cubed. There's nothing I can simplify. That is my answer. Letter E. I have log base 3 4x plus 2 log base 3 5y. The first thing you always want to take care of are those powers. This was 2 times the logarithm, so I'm going to bring it up, making it an exponent. But it's an exponent to both the 5 and the y. So this is going to be log base 3 of 4x plus log base 3 5 squared and y squared. Now I can rewrite them as a single logarithm. Log base 3, so I've taken care of those. My addition changes to a multiplication. So I'll take 4x times 5 squared, which is 25, and y squared. Simplify anything you can, and I get log base 3 of 100 xy squared. So that was contracting logarithms, taking 2 or 3 or 4 into one single logarithm. In the next set of problems, we're going to expand each logarithm. So you're going to start with 1, and your answer is going to have multiple logarithms in it. In fact, for every letter or number that you see, you should have a logarithm. So this is log of x. I have log of y and log of z. These are all being multiplied together. So multiplication is going to change to addition, which means that I will add the 3 terms, giving me my final answer. Letter B. What happens if you have multiple things in the denominator? I know I'm going to end up with 3 different logarithms. So let's write that out. Log x, log y, and log z. Between the x and the yz, y and z are together in the denominator. So I'm going to group them together in my answer. There is a division sign, and division changes to subtraction. So I'm going to do log x minus log y plus log z. Between the y and z was a multiplication, so I changed it to addition. You can leave your answer that way, or you can take it one step further and distribute the negative sign. So you'd have minus log y minus log z. Letter C. Let's do one that deals with the power. Go ahead and give this one a try. Push pause while you work and then resume play to check your answer. This is what I got. I split up my logarithms. I had one for the 6, the x cubed, and the y. The cube I brought to the front using my power property, giving me my final answer, log 6 plus 3 log x plus log of y. All right, one more that I want to do together. That's what you do when you have radicals. The first thing is to change that radical into an exponent. Radical exponents are rational exponents. I can change the square root into the 1/2. The next part, I know that I'm going to need 6 different logarithms. There's my 6 logarithms. The numerators are all multiplied together, so add them. After the t, I find my division sign, so I'm going to subtract. Put your denominator together, and within the denominator, I'm going to add. 5 times w becomes log 5 plus log of w. The last thing to take care of is that exponent. Using my power property, I move it to the front of the entire problem, and it's 1/2 times everything. Great, go ahead and try letter E. Push pause and resume play when you're ready to check your answers. And this was my answer. Log 5 plus log x is my numerator, minus log 4 plus log y is my denominator. One last formula to go over. It's called the change of base formula. Formula is log base b of m can be solved using your calculator, typing in the log of m divided by the log of the base. So let's see how this works in a problem. Log base 2 of 15. If I were to write this as an exponent, I would say 2 to some power is 15. And that I can't figure out, but what I can do is change it or use the change of base formula. 2 is my base, 15 is my m. I'll type in log m divided by log b, and your answer is 3.91. And you should type it in the calculator exactly the way it looks. You have to close off your parentheses. What this means is approximately 2 to the 3.91 is equal to 15. I had to round, so it's not an exact answer. Let's try again. Log base 5 of 6. 5 to what power is equal to 6? Match it up with your base and your m. Put it into our formula, log m divided by log b. And you should get the answer 1.11. 5 to the 1.11 power is approximately 6. Right, try the last one. Log base 6 of 17. Push pause to check your answer. My answer was 1.58. And that concludes lesson 7-4.